Reality resembles a versatile surface, much like a trampoline net. Imagine twisting this trampoline net into the shape of a pretzel and granting yourself the ability to travel backward in time. Have you ever pondered what truly lies beyond our world? What extraordinary mysteries the universe might be hiding? Well, prepare for an astounding revelation, a discovery so monumental that it challenges everything we thought we knew about the cosmos. Take a moment to embrace this mind-bending journey as renowned American physicist Michio Kaku unveils a groundbreaking theory, one that upends our understanding of the universe. This theory has recently been brought into the spotlight, thanks to none other than the extraordinary James Webb Space Telescope, JWST, which has delivered evidence that suggests time, as we know it, may not even exist. The JWST, which launched on Christmas Day 2021, is essentially the bigger and more advanced sibling of the Hubble Space Telescope. Stationed in space, it illuminates some of the darkest and most distant corners of the universe, functioning as a veritable time machine. With its powerful infrared instruments, it allows us to peer into the past, capturing images of objects so ancient and faint that even the Hubble could not detect them. The JWST has provided a glimpse into the distant reaches of space, including galaxies and celestial bodies from the early universe. These entities have long eluded us, but thanks to JWST, the puzzle pieces of the universe are slowly falling into place. Now, imagine yourself strolling through an art exhibit, admiring the stunning images captured by JWST. Galaxies light up the cosmic canvas, yet among the scientists and astronomers, there's a palpable sense of shock and confusion. It's as though they're examining a Picasso painting in a room full of hyper-realist artwork. The common sentiment is one of surprise. But what exactly has shaken their understanding of the universe to its core? The JWST's discoveries have rattled the foundations of a theory long held dear by cosmologists: the Big Bang Theory. For decades, this theory has suggested that the universe began with a massive explosion approximately 13.8 billion years ago and has been expanding like a balloon ever since. This notion has been the bedrock of cosmology, but now, the latest images from the JWST are calling its validity into question, sending ripples of astonishment throughout the scientific community. Why is everyone so perplexed? The galaxies captured by the JWST aren't behaving as they should according to the Big Bang model. They're too small, too smooth, too ancient, and there are far too many of them. Let's break it down. If we think of the universe as an expanding balloon, galaxies should appear smaller as they move farther away from us. After a certain point, they should even start looking bigger, as their light would have left them when they were closer to us. This odd but fundamental quirk is central to the concept of an expanding universe. However, the galaxies in JWST's images don't follow this pattern. They appear about the same size as nearby galaxies, even though they should be much smaller if the universe is expanding as we believe. It's like expecting to see distant friends as tiny specks, only to find them looking as though they're standing right next to you. Even more confusing is that these galaxies, though far away, are brighter and pack more mass than our own Milky Way, yet appear smaller. This contradicts what we would expect in an expanding universe. For example, consider a galaxy called GHC2, spotted by JWST. It's far brighter than the Milky Way but measures just 300 light-years across, compared to the Milky Way's 50,000 light-year span. Its brightness per unit area is over 1,000 times greater than the most luminous galaxy in our local universe. What's more, its density, along with other newly discovered galaxies, is multiple times higher than that of galaxies we see around us today. So what does this mean? It suggests that the idea of an expanding universe, and by extension the Big Bang Theory, may be crumbling. These findings have sparked immense debate among astronomers and cosmologists. The images are raising difficult questions that challenge our most fundamental assumptions about the universe. Over the years, the Hubble Space Telescope had also captured intriguing images, indicating the presence of dense, compact galaxies. But with JWST's far more powerful infrared capabilities, the enigma has only deepened. Researchers once believed that these tiny galaxies collided and merged over billions of years, eventually forming the larger galaxies we see today. It was like imagining toy cars crashing into each other until they grew into full-sized SUVs. But here's the twist. JWST has found no evidence of these galaxy collisions. You would expect to see signs of such mergers, galaxies that look warped, distorted, or damaged, like cars after a fender bender. Yet instead, JWST reveals galaxies that are smooth, pristine spirals, much like those near us. In fact, a recent study dubbed The Surprise highlights that there are 10 times more of these spiral galaxies than previously anticipated. This discovery is akin to finding a bustling highway full of speeding cars, but with no accidents in sight. It's a significant blow to the collision hypothesis. Without evidence of these mergers, the idea that these tiny galaxies somehow grew into their larger counterparts falls apart. If they didn't grow in size, then they weren't small to begin with, and the optical illusion we'd expect from an expanding universe seems to vanish. Without this illusion, the concept of cosmic expansion loses ground. Hence the growing discomfort among Big Bang proponents. Moreover, the existence of these small, smooth galaxies suggests that the universe may not be expanding at all. And if the universe isn't expanding, then the Big Bang theory faces a serious blow. There's another crucial aspect to consider: the age of the stars. According to the Big Bang theory, everything in the universe originated after that initial explosion. But if these galaxies existed before the Big Bang, it would mean the Big Bang never happened. This revelation could radically alter our understanding of the universe's origins. Consider the James Webb Space Telescope as a time machine. As Michio Kaku describes it, the telescope is capable of peering billions of years into the past, capturing images that shed light on the birth of the universe. But JWST doesn't just take ordinary pictures. It's focused on the infrared spectrum, revealing galaxies so distant that we would never be able to see them with our naked eye. And here's the kicker: the colors captured by JWST aren't just beautiful, they tell the age of the stars in these galaxies. Young, hot-burning stars burst with intensity, while older stars glow with a more subdued light. This entire revelation could upend much of what we believe about the universe. As we continue to analyze the data from the JWST, strikingly blue stars contrast with their cooler, more stranger and more complex than we ever imagined. Such as our sun. What lies ahead could forever change our understanding of time, by analyzing these colors, and everything in between. Astronomers can estimate the ages of star populations in distant galaxies. According to the Big Bang theory, the most distant galaxies in the James Webb Space Telescope, JWST, images capture a snapshot of the universe from around 400 to 500 million years after its birth. Yet, some of these galaxies appear to contain stars that are over 1 billion years old, which presents a major challenge to the Big Bang model. If you've been following this theory, you know that nothing should be older than the Big Bang itself. Another expectation based on the prevailing theory is that as we look deeper into space, and thus further back in time, we should encounter fewer and fewer galaxies until we reach a period known as the Dark Ages, when no galaxies existed. However, the JWST's discoveries tell a different story. Large galaxies, similar in size to the Milky Way, were already relatively common just a few 100 million years after the supposed Big Bang. In fact, there are about 10 times more galaxies than predicted at redshifts above 10, raising the question of how so many massive galaxies could have formed in such a short time. The answer most likely is that they couldn't, at least not under the constraints of the Big Bang theory. These revelations are challenging our fundamental understanding of the universe. Moreover, they pose a deeper philosophical question about the nature of time itself. Modern physics assumes time to be a fundamental concept, intricately linked to Einstein's theories of relativity and many other scientific principles. But what if time, as we perceive it, doesn't actually exist? Although this idea is radical, it's not entirely new. Some theoretical physicists have proposed that time may not be a core component of reality, suggesting that our perception of time could be an emergent property or even an illusion. When it comes to the universe's origins, this could mean that our interpretation of events unfolding in sequence, starting with the Big Bang, may be fundamentally flawed. If time as we understand it doesn't exist, then the concept of a singular beginning like the Big Bang becomes meaningless. This would drastically change our understanding of the universe, requiring a new framework that doesn't rely on time as an essential element. Instead, the universe might be better understood as a whole, with space-time existing without a sequential beginning or end. This shift in perspective could help explain some of the puzzling observations made by the JWST, such as the existence of mature star systems in what we thought was the early universe. If time isn't a central property, these galaxies could indeed be older than the Big Bang, without violating the laws of physics. Without the constraint of time, the universe may not have a singular beginning at all, suggesting a more complex and intertwined cosmic structure. In this new model, the universe could exist in a state where the past, present, and future are not linear, but coexist in ways far beyond our current understanding. This would have significant implications not only for cosmology but also for how we interpret existence itself, possibly leading to groundbreaking discoveries about the nature of reality. The ongoing debate between the Big Bang theory and the steady-state theory illustrates two fundamentally different views of the universe. The Big Bang theory describes a universe with a definite beginning and a history of continuous expansion. In contrast, the steady-state theory suggests that the universe has no beginning or end, maintaining a constant average density with new matter continuously created to fill the gaps left by expansion. In summary, the JWST is not just offering a new lens through which we can observe the universe. It's also providing data that challenges our long-held assumptions about the universe's history. These observations could indicate that the Big Bang theory, as we currently understand it, may not be entirely accurate. Instead, the universe may be eternal, with no specific beginning or end. This doesn't mean that all of our understanding is wrong, but it suggests that there are deeper, more complex systems at work that we have yet to fully comprehend. It's an exciting time for astronomy and cosmology, as we stand on the brink of potentially monumental discoveries that could reshape our understanding of the universe and reality itself. Imagine reality as being woven together like a fabric or a trampoline net. Now, twist that net into a pretzel and imagine navigating through time. These ideas set the stage for profound investigations into the mysteries of the universe. Recently, renowned American physicist Michio Kaku revealed discoveries that challenge our fundamental understanding of the universe. The JWST, launched on Christmas Day 2021, has become an unparalleled instrument for probing the depths of space. Unlike its predecessor, the Hubble Space Telescope, the JWST's advanced infrared instruments can detect ancient and faint objects with astonishing clarity. The JWST has revealed distant galaxies and star systems from the early universe, shedding light on their characteristics and behaviors. As astronomers analyze the images, they are confronted with surprising observations that defy the traditional Big Bang theory. According to this widely accepted theory, the universe began with a massive explosion around 14 billion years ago, expanding ever since. However, the galaxies captured by the JWST appear smaller, smoother, and surprisingly old, contradicting the notion that galaxies should appear larger as they move farther away due to the universe's expansion. This discrepancy raises fundamental questions about the nature of cosmic evolution and the validity of our current cosmological models. One striking discovery is GHZ2, a galaxy identified by the JWST that shines brighter than our Milky Way, yet spans only 300 light-years in diameter, compared to the Milky Way's 50,000 light-year diameter. The density and brightness per unit area of this galaxy are significantly higher than those observed in nearby galaxies, presenting a puzzle for astronomers. The JWST's images also reveal galaxies with higher redshifts, indicating faster apparent speeds of recession from us, challenging our understanding of how redshift relates to galactic distances in an expanding universe. Furthermore, the JWST has uncovered a surprising abundance of mature spiral galaxies in what was thought to be the early universe. These galaxies appear as fully formed structures, with stars that seem older than expected according to the Big Bang timeline. If these galaxies existed before the supposed birth of the universe, it calls into question the very notion of a singular beginning event like the Big Bang. This realization has sparked intense debate among cosmologists, pushing the boundaries of how we interpret time, space, and cosmic origins. Beyond the observational challenges to the Big Bang theory, the JWST's findings also provoke philosophical inquiries into the nature of time itself. Modern physics operates on the assumption that time is a fundamental aspect, intricately woven into Einstein's theories of relativity and our understanding of the universe. However, some physicists have hypothesized that time may be an emergent property or even an illusion, challenging the linear progression of events from a single starting point. The implications of these discoveries extend far beyond astronomy. They suggest that our current models of the universe may be incomplete, requiring a broader framework that accommodates nonlinear time and an eternal universe. This shift in perspective could redefine our understanding of existence itself, presenting a universe where past, present, and future coexist in a complex interplay. In summary, the JWST is not only capturing stunning images of distant galaxies but also rewriting our cosmic narrative by questioning the foundations of the Big Bang Theory and our concepts of time. The JWST invites us to reconsider the origins and evolution of the universe, marking a pivotal moment in cosmology that promises profound insights capable of reshaping our understanding of the universe and our place within it.